comparison of the length of 1 degree, 1 minute, and 1 second. To give you an idea of how small a degree is, how small a minute is, and how small a second is, we have a chart here. Let's say we had a 12-inch line. If we start out with a 12-inch line and we make this angle 1 degree, we know that we can find this length here. Same thing if we make this angle 1 minute or 1 second. Now in reality, we could never really draw this so you can see it. So these are not drawn to scale, but this will give you an idea of how small they are. Let's start off with the degree. 1 degree, we know we can take the side opposite equals side adjacent times the tangent of that angle. We've learned that formula before. The tangent of 1 degree is 0.01745. Multiplying by 12, which is the adjacent side, I get 0.2094. So 1 degree would make this x right here equal to 0.2094, which is a little over 3/16 of an inch, or less than 1/4 of an inch. Now remember, when we go from 1 degree to 1 minute, we have actually taken this degree and split it into 60 equal parts. So this is 1/60th of this. When we look at 1 minute, our side opposite is our missing side still. Our adjacent side is still 12, but I need the tangent of 1 minute. Remember that before I can put that in the calculator, I need to change it to decimal degrees. When I do, I come out with this outrageously long answer, giving me 0.00349, which means this line here, in reality, is 0.00349. If you were just to compare these two decimals, you can see this is much larger. But this here is approximately the thickness of a piece of paper. Let's go to 1 second. Now it's hard to believe that we took that minute and divided it into 60 equal parts. But now we're going to take just one of those parts and divide it 60 more times and get 1 second. We're looking for the side opposite. The adjacent side is still 12, but now we have 1 second. So we need to convert that to a decimal degree, remember, before we put it into the calculator to get this decimal answer. When we multiply by 12, we get that this line is 0.00058. That's a very small decimal. And I want you to think about this. If I were to take one strand of hair and split it into 40 equal little pieces, 1/40th of that strand of hair would be as long as that line there. This is just used for comparison to make you see how small this really is. In reality, you will never need this kind of work unless you're doing precision work, and then you'll need to know how to do your conversions.
Surveyors check the length and height of properties. The surveyor with his instrument shoots a laser beam to a reflecting lens on a pole. Now, knowing the exact distance and the angle of the two sites, the surveyors can determine the exact height of the new distance from where the instrument is located. Let's look at this surveying problem. The surveyor over here, and this is an exact height from here to here, whatever it is, let's say it's 5 foot. And this, let's say this is the exact height also to where the pole is standing is 5 foot. The surveyor shoots a beam and it bounces back and the instrument measures that distance. Say it's 300 feet. What is the distance of x Now this could be tilted up or down or level. If it's level, this will register no angle. So it depends which way that angle, which the surveyor can determine what that angle is. So that's 300 feet, and this is X, and this angle is 28 minutes and 4 seconds. What is the height of X? Now notice again, this is 28 minutes, not degrees. It's not even 1 degree. It's just 28 minutes and 4 seconds. Now let's look at this famous Indian name to solve our problem. And what do we have here? SOHCAHTOA. Now we have the angle that we got to find. So this is the angle, 28 minutes, 4 seconds. So what do we have? We have here, it's the hypotenuse. That's 300 feet. And that's this line that's on an angle. This is a right triangle. So we have the angle, 28 minutes and 4 seconds. We have the hypotenuse. And this would be the opposite. So we need to find this name, SOHCAHTOA. So we have the opposite and hypotenuse, so it would be sine. So sine of 28 minutes and 4 seconds equals opposite, which is the x, over the hypotenuse, which is 300. Let's cross multiply, isolate the x. X equals sine of 28 minutes, 4 seconds, multiplied by 300. Now let's put the sine 28 minutes and 4 seconds into the calculator. All right, we put 28, but remember, this is not degrees, so we got to put a decimal point in first. 0.28. Now this is 4 seconds. Now, if you just put a 4, that means 40 seconds. So it's 4 seconds, so we got to put 04. That's 04. Now, you may be tempted here to press the sign button, but that is wrong. Remember, degrees must always be in decimals of degrees. I cannot stress this enough, because if you're going to press sine here, you're going to get a wrong number. Now, if you have 28, sine of 28, you don't have to go to decimal degrees, because decimal degree of 28 is 28. But when you have minutes and seconds, you have to come over here and convert that into decimal degrees and press that DD. Now we press the sine button. Sine, that's 0.008164171 times 300 equals, and it's 2.4492. So x equals 2.449, and the 2 gets rounded up to 3 feet. So when the surveyor reads his laser beam, comes back, it's 300 feet, and then remember, that's the hypotenuse. The angle of elevation is 28 minutes and 4 seconds. This height then is 2.4493 feet. And I want to stress this. Remember, degrees must always, if you don't remember that, you're going to make many mistakes. Degrees must always be in decimals of degree. Let's look at another problem. This is a sine bar that is commonly used in machine shops, and the dimension between these two diameters is 5 inches. Now we have a print that calls for 22 degrees and 15 minutes, and we want to grind an angle on here. What we would do, we would set this sine bar. At 22 degrees, 15 minutes is actually 22 degrees and 1/4 of a degree. 1 minute has 60 minutes in it. So we put into our calculator 22.25 sine, and since this is 5 inches, we'll multiply that by 5 inches, and that is 1.893. Now these are precision gauge blocks that are commonly used to set heights for various reasons, and I have it already set, so we'll take these gauge blocks and put it underneath the sine bar, and I will place this part that I want to grind over here on this squaring block. I will clamp this, and then I will double check that it fits right. So now I can take this part to the grinder and grind a precise degree of 22 degrees and 15 minutes.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.